Auzu billahi minash shaitanir rajeem. Bismillahir rahmanir rahim. Dear students, Assalamu alaikum. My name is Dr. Azhar Ali, Assistant Professor, Electrical Engineering Department, Sarhad University, Peshawar. Dear students, you know, in the last two lectures we have discussed the solution of nonlinear equations by Newton-Raphson method and fixed point iterative method. And today we are going to learn solutions of nonlinear equations by secant method. And this is the second lecture of 5th week for the course numerical analysis. Now, to derive the secant method, dear students, since we have a nonlinear equation, so this is the curve of the nonlinear equation, and here the domain point xi plus 1 and xi plus 2, and the y vertical points are f of xi minus 1, and here we have a point xi f of xi. Now, since, dear students, you know that the Newton-Raphson method is given by xi plus 1 is equal to xi minus f of xi divided by f dash xi, and from this geometry is by the Newton-Raphson method. Now, approximate the derivative of the function from this geometry. We obtain f dash, the derivative of the function at xi is equal to f of xi minus f of xi minus 1 divided by xi minus 1, and this is equation number 2. Now, substituting the value of f dash at xi from equation number 2 to equation number 1, we obtain the secant method as xi plus 1 minus f of minus xi plus 1 is equal to xi minus f of xi into xi minus 1 divided by f of xi minus f of xi minus 1. Now, the derivation of the secant method, this is the second process for the derivation of the secant method. Now, the geometrical similar two triangles, there are two similar triangles. So the geometric similar triangles gave us AB, this is the AB divided by AE is equal to DC divided by DE, and this can be written as f of xi divided by xi minus xi plus 1 is equal to f of xi minus 1 divided by xi minus 1 minus xi plus 1. On rearranging, the secant method is given by xi plus 1 is equal to xi minus f of xi into xi minus 1 divided by f of xi minus f of xi minus 1. So, the algorithm for the secant method, procedure for the secant method, in the procedure, step number 1, calculate the next estimate of root from the two initial guesses. For the secant method, we choose two initial roots, x0 and x minus 1, and then putting their values in the secant formula, xi plus 1 is equal to xi minus f of xi into xi minus 1 divided by f of xi minus f of xi minus 1, and find the absolute relative approximate error by this formula. Absolute epsilon alpha is equal to absolute xi plus 1 minus xi divided by xi plus 1 multiplied 100. And step number 2, find if the absolute relative approximate error is greater than the pre-specified relative error tolerance. If so, go back to step 1, else stop the algorithm. Also check if the number of iterations has exceeded the maximum number of iterations. Now let's move on an example. Suppose we have a non-linear equation f of x is equal to x cube minus 0.165 x square plus 3.993 multiplied 10 raised to the power minus 4. So using the secant method to find the root of this equation and conduct 3 iterations to estimate the root of this equation. Also we have to find the absolute relative approximate error and the number of significant digits at least correct at the end of each iteration. So first of all, assume the initial guesses for the function f of x is equal to 0 and the initial values 2 roots x minus 1 is equal to 0.02 and x naught is equal to 0.05. Now from the first iteration, the estimate of the root is, using the secant method formula, we obtain x1 is equal to x naught minus f of x naught into x naught minus x minus 1 divided by f of x naught minus f of x minus 1. So dear students, from this expressions, note that to estimate the function at x naught and to estimate the function at x minus 1. So this is the value of x naught minus this is the result of the function at x naught. So 0.05 whole cube minus 0.165 into 0.05 whole square plus 3.993 multiplied 10 raised to the power minus 4 into, now this is the value of x naught and this is the value of x minus 1, and divide by f of x naught. Again estimate the function at x naught minus estimate the function at x minus 1, and after simplification we get x1 root is equal to 0.06461. Now for this first iteration, to find the absolute relative approximate error, absolute epsilon alpha, this is the absolute relative approximate error at the end of this first iteration, which is given by a formula absolute epsilon alpha is equal to absolute x1 minus x naught divided by x1 multiplied 100, putting the value of x1 and the value of x naught divided by the value of x1 multiplied 100, we obtain the absolute relative approximate error is 22.62%. Now dear students, the number of significant digits at least correct is 0, as you need an absolute relative approximate error of 5% or less for one significant digits to be correct in your result. Now iteration number 2, the estimate for the second x2 root using the secant method formula, x2 is equal to xi minus f of x2 is equal to x1 minus f of x1 into x1 minus x2 divided by f of x1 minus f of x naught. Now dear student, from this expression note that estimate the function at x naught and estimate the function at x1 and estimate the function at x naught, and putting the values of x1 and x naught. So this is the value of x1 minus, now estimate the function at x1, this is the value of x1, 0.06461 whole cube minus 0.165 into 0.06461 whole square plus 3.993 multiplied 10 raised to the power minus 4 into, now this is the value of x1 and minus this is the value of x naught divided by now estimate the function at x1. So this is the estimated value of the function at x1 minus this is the value of the function at x naught, and after simplification we get the value of x2 as a 0.06241. Now dear students, again find the absolute relative error for the second iteration, which is given by absolute value of epsilon alpha is equal to absolute value of x2 minus x1 divided by x2 multiplied 100. Now putting the value of x2, this is the value of x2, 0.06241 minus, this is the value of x1, 0.06461 divided by the value of x2 multiplied 100. Subtract this value from this value and then divide the result by 0.06241 and multiplying by 100, we get the relative absolute approximate error is the absolute relative approximate error is 3.525%. Now dear students, the number of significant digits here at least correct is 1, as you need an absolute relative approximate error of 5% or less. Now for the third iteration, estimate the next root for the non-linear equations, which is equal to x3, and x3 is equal to x2 minus f of x2 into x2 minus f of x1 divided by f of x2 minus f of x1. So using the secant method formula, the x3 root is equal to x2 minus f of x2 into x2 minus x1 divided by f of x2 minus f of x1. So putting the value of x2, this is the value of x2 minus, and now estimate the function at the value of x2, which is 0.06241 whole cube minus 0.165 into 0.06241 whole square plus 3.993 multiplied 10 raised to power minus 4. Dear students, in each iterations, note that estimate the function at x1, x2 and x0. Estimate the function at x0, the function at x1 and the function at x2 up to third iteration. So dear students, note that to estimate the function at x2 means that they are putting the value of x2 in the given equation. This is the given equation, which is in the form of x cube minus 0.165 x square plus 3.993 multiplied 10 raised to power minus 4. So for each iterations, suppose here we find x3, so x3 is equal to x2 minus f of x2 into x2 minus x2 minus x1 divided by f of x2 minus f of x1. So for this iteration, I would like to tell you that estimate the function at x2 mean putting the value of x2 in the given function, and f of x1 mean to estimate the function at the value of x1, and this means that putting the value of x1 in the given function. So we obtain x3 is equal to 0.06241 minus, now estimate the function at x2. This is the value of x2 for the function 0.06241 whole cube minus 0.165 into 0.06241 whole square plus 3.993 multiplied 10 raised to power minus 4. This is the value of the function at x2 into the value of x2 0.06241 minus, this is the value of x1 0.06461 divided by, now again estimate the function for x2, which is given by 0.06241 whole cube minus 0.165 into 0.06241 whole square plus 3.993 multiplied 10 raised to power minus 4 minus, now estimate the function at x1 0.05 whole cube minus 0.165 into 0.06461 whole square plus 3.993 multiplied 10 raised to power minus 4, and after simplification we obtain the value of x3 is 0.06238. Now dear students, again find the absolute relative approximate error for the third iteration, which is given by absolute value of epsilon alpha, which is equal to absolute of x3 minus x2 divided by x3 multiplied 100. Now putting the value of x3, this is the value of x3 from the previous third iteration, this is the value of x3. So x3 0.06238 minus, now putting the value of x2, which is 0.06241 divided by the value of x3 0.06238 multiplied 100, and after simplification we get the absolute error for the third iteration is 0.0595%. This is the absolute relative approximate error for the third iteration. And dear students, note that the number of significant digits at least correct is 5, as you need an absolute relative approximate error of 0.5% or less. Now dear students, note that in the secant method converts in fast. Convergence of secant method is so fast if it converges, and secant method requires two guesses, two initial values. They do not need to bracket the root, and there is a possibility of divergence if the two roots lies on the same side of the curve. And dear students, also note that in the secant method the given function is not required to change sign between the estimates. Now let's move on another example. Suppose we have a nonlinear equation f of x is equal to 2 cos hyperbolic x into sin x minus 1. Dear students, try yourself to find the roots of this equation correct to 3 decimal places, and here I want to tell you for the initial value, consider x minus 1 is equal to 0.4 and x naught is equal to 0.5. Now using the secant method to find the roots of this nonlinear equation correct to 3 decimal places, and this is home task for you. Now this is the end of this segment. Thank you. Allah Hafiz.